Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Hello, everybody. Welcome back to another episode of the Space on Earth podcast. I'm one of your co-hosts, Wyatt Wade.
And I'm Havilah Hughes.
And today we have another interesting topic. Space missions rarely go exactly as planned. Spacecraft age, hardware fails, and sometimes the only way to save $1 billion mission is to invent something that's never been done before. That's exactly what happened with NASA's Swift Observatory. After years of studying some of the most energetic explosions in the universe, Swift found itself facing a problem that engineers couldn't solve from the ground. Instead of giving up, NASA launched an entirely new spacecraft, not to replace Swift, but to rescue it. Today we're telling the story of the Neil Gehrels Swift Observatory, the science it accomplished, and one of the most unusual rescue missions NASA has ever attempted. So, Havilah, let's start at the beginning. What exactly is the Swift Observatory?
Well, the Swift Observatory was launched November 2000. It is a joint mission between NASA, the United Kingdom, and Italy that is designed to study gamma ray bursts, the most energetic explosions in the universe. Unlike most telescopes, Swift doesn't stare at one object. It rapidly turns to observe sudden cosmic events.
Why is it called Swift?
It is named for its ability to rapidly slew across the sky. It can automatically point towards new explosions within about a minute, which is one of the fastest reacting observatories ever built.
You mentioned gamma ray bursts. What exactly are those?
Gamma ray bursts are the brightest explosions in the universe that can briefly outshine entire galaxies. They are usually caused by massive stars collapsing into black holes and/or neutron stars merging. They last from milliseconds to several minutes, and they produce an afterglow that can be studied for days.
That's very interesting. How does Swift actually detect these gamma ray bursts?
There are three primary instruments: Burst Alert Telescope, BAT, X-ray Telescope, XRT, and Ultraviolet Flush Optical Telescope, UV. The workflow of these is that the BAT detects bursts, which then the spacecraft rotates automatically, so that the XRT and the UVOT immediately begin observations. The position is then sent worldwide within seconds to the other telescopes like the Hubble telescope, which can then join in the observations.
That's very cool. So Swift has been operating for basically 2 decades at this point. What have been some of its biggest discoveries?
There have been thousands of gamma ray bursts detected, which have helped discover kilonowaves. It has also observed neutron star merges, studied supernovae, observed tidal distribution events, monitored black holes, studied comets, and even observed gravital wave flow follow-up events.
So basically, Swift does a lot more than just gamma ray bursts.
Yes. And it has become one of NASA's most versatile observatory transit event and frequently supports other observatories. So Swift has been operating just fine for more than 20 years. Why did NASA suddenly need to rescue it?
That's a really good question. Basically, Swift doesn't have its own propulsion system. It has an attitude control system, so it can rotate on all axes, but it doesn't have any thrusters to increase or decrease its relative speed in orbit. And every spacecraft in low Earth orbit experiences a very small but still impactful amount of atmospheric drag. Normally, this happens very slowly, but recent solar storms heated and expanded the Earth's atmosphere, which began to drag down Swift. Swift's orbit began dropping much faster than engineers had planned, and without intervention, Swift would have re-entered the Earth's atmosphere by the end of this year. So, since Swift didn't have its own propulsion system, that meant NASA had to bring an entirely different spacecraft to Swift instead. So NASA went to Catalyst Space, which is an Arizona-based startup, and asked them to develop a spacecraft that could rendezvous and boost Swift.
So what exactly is Link?
It's a robotic surfacing spacecraft that was developed in less than a year. It took 250 years from just design to finished manufacturing. It has cameras, autonomous navigation, robotic arms, and Hall effect thrusters, which are very efficient. And it's going to basically dock or grab onto Swift and ignite its engines to boost Swift's orbit so it doesn't come crashing down back into our atmosphere.
Wow. But how do you grab a satellite that was never meant to be grabbed?
Very good question. It's one of the biggest engineering challenges. Link will first approach slowly. It will image Swift from every angle, and then back on the ground, engineers will determine the safest grab points. The 3 robotic arms on Link will then grab onto Swift. Once attached, Link will slowly boost the orbit over several months. Hall effect thrusters, they're very efficient, but they are very, very low thrust. So it's going to do its job and stop Swift from burning up in her atmosphere. And also, I guess one of the benefits is that gentle thrust prevents accidental damage to Swift.
What vehicle actually took Link to orbit?
This was one of the most interesting things about this mission to me, is that it was launched from a rocket, obviously, but the rocket was launched from a plane. So since 1990, good old Northrop Grumman has been launching their Pegasus solid rocket booster that goes actually into orbit from a plane. I've always found this idea of getting to orbit really interesting. I guess it's similar to one of SpaceX's concepts of a rocket, where before their Falcon 9 rocket actually flew, they were still building the Falcon 1. They wanted to make the Falcon 5, where it was just basically just like Falcon 9, but with 5 engines instead of 9, and a bit smaller. And they wanted it to be just like Pegasus, where the rocket is attached to the belly of a plane, which Pegasus uses, and Northrop Grumman uses a modified Lockheed L-1011 TriStar jetliner. On the pictures, it just looks like a normal 737, but basically, the actual rocket part is attached to the belly of the plane. The plane lifts off, ascends to 40,000 feet. The rocket part detaches, falls for about 5 seconds. It then ignites its engines and then goes into space. I never really understood the idea of that, because 40,000 feet, that's only about 12.19 kilometers. I don't get how it's more efficient, because basically, look at it like this. The Kármán line, the globally recognized boundary of space, starts at 100 kilometers. 40,000 feet equals just about 0.19 kilometers. So, launching a rocket from a plane that's only 12% the way to space, it's an interesting idea. And it's proved itself. It's launched 46 times with a success rate of 91.3%. But I honestly don't think this thing has a future. It's very old. It's been flying since 1990.
Why did NASA use Pegasus instead of Falcon 9 or another conventional rocket?
The mission actually did require a very specific low inclination orbit. And since Pegasus does launch from a plane, it could launch almost anywhere. The biggest part about why they did launch it from Pegasus is that it did condense the mission timeline. That means it was able to launch faster on Pegasus than a different rocket. Because, yet again, Catalyst Space, 250 days to go design to final product for the spacecraft, which is very insane.
Once Link reaches Swift, what happens?
Good question. Link will just do the initial spacecraft checkout and then raise Swift's orbit to around 240 kilometers or 150 miles. And then Swift is saved. It can resume scientific operations, and this is going to extend Swift's life for years.
Wow. Do you think this mission is bigger than just saving Swift?
Absolutely. I mean, this is the first US attempt to rescue an operational satellite already in orbit, and it demonstrates satellite servicing. There are 4 space shuttle missions to service the Hubble Space Telescope. If I remember correctly, they just went up there to replace parts on the telescope during EVAs. They didn't actually boost the space telescope, but this is still a first for a robotic attempt to rescue an operational satellite. And it could lead to servicing future science missions. It has the potential applications for commercial satellites. NASA even suggested similar techniques that could someday help missions like the Hubble Space Telescope, since the only crewed spacecraft that could do repairs is Crew Dragon right now or Starliner, but that's not happening. So, Havilah, why do you think missions like this resonate with people?
Well, engineers solve unexpected problems, which shows perseverance. Perseverance is an important thing that all humans have, not just scientists. Science doesn't end when a spacecraft gets old, because every mission has a story. Just like each of us, we all have our own stories. Innovation often comes from necessity. So, like scientists and engineers innovate, we can also innovate in our own lives.
Interesting. Yeah. I mean, we've talked a lot about the engineering behind this rescue. What do you think this mission says about the people behind NASA?
Engineers are really persistent problem solvers. They don't just give up when a mission encounters challenges. Space exploration requires such a large amount of creativity as much as technical knowledge. This shows the determination and dedication of teams who have worked on Swift for so many decades.
Yeah, I mean, exactly. Swift has been making discoveries since 2004. I mean, why do you think preserving scientific missions like this is important?
Scientific missions build long-term data sets. Consistency is so valuable for researchers. Extending a mission can be so much more valuable than just starting completely all over, because every extra year can lead to unexpected discoveries.
Yeah. Do you think missions like Swift could change the way people even see the universe?
Yeah, they make distant cosmic events feel so much more real. This helps people understand that the universe is acting and constantly changing, which inspires curiosity about our place in the cosmos. This turns abstract science into something people can really connect with.
Really good point there. I mean, the rescue mission itself is a story of solving a problem. Why do you think stories like this are important to share?
Well, it shows that science, it isn't always a straight path. Failures and challenges, they're a big part of discovery. This demonstrates resilience and teamwork. It inspires students who think mistakes mean giving up, when really, oftentimes, it's a lot about perseverance and overcoming the challenges as a team.
You know, NASA did release some incredible images and animations from missions like Swift. Do you think art and visualization could possibly help people understand science more?
Yes, absolutely. Most people can't interpret just raw scientific data. Artists and graphic designers turn data into understandable visuals. Visualization helps explain amazing, complex ideas, and they make discoveries accessible to the public. Many people first became interested in science because of amazing, beautiful imagery, which can really lead to inspiration in the art realm. Artists often take their inspiration from the images that scientists took.
Yeah. Um, Spacecraft like Swift and Perseverance and Curiosity and all the space shuttles are often given names instead of numbers. Why do you think that matters?
It makes the mission more memorable and helps the public really connect with them. As opposed to just being a number, it has a name. And this gives each mission its own identity and story, which encourages people to follow missions over so many years.
I mean, space has inspired artists for really centuries at this point. Do you think missions like Swift could continue that tradition?
Yeah, space inspires paintings, music, books, film, and photography. Every new discovery gives artists a new story to tell. Science and art are both begin with curiosity. Missions like Swift expand our imagination of what is actually possible. If someone listening is interested in space but doesn't see themselves becoming an engineer, what roles do missions like Swift have for them?
Oh, there is a bunch. You have science communication, graphic design, education, history, photography, writing, public outreach, which is my personal favorite, and space exploration depends on many different careers, not just scientists and engineers.
Yeah, that is so true. If someone made a movie about the Swift rescue mission, what do you think would make it such a compelling story?
That's a good question. I mean, it's it starts with a spacecraft that's been working pretty fine for decades, and then now there's a ticking clock scenario where its orbit is slowly decaying and it could crash into Earth any year, any month. And now engineers are racing against time and they use a really weird, unusual air launched rocket and rendezvous with the spacecraft. And, you know, boom, perseverance and innovation saved that spacecraft and saved the agency, NASA, a lot of money so they didn't have to build a new spacecraft and launch it into space.
Yeah, really shows the perseverance and teamwork. Do you think we'll see more rescue missions like this?
Honestly, it's very likely. Satellite servicing is growing. Old, expensive satellites are needing repairs, like the Hubble Space Telescope, and also future telescopes may be designed for maintenance. And it could definitely become routine in Earth orbit, which is really cool. But that is going to be it for us today. Thank you for listening to the 15th episode of season 2 for the Space on Earth podcast. I've been one of your co-hosts, Wyatt Wade.
And I'm Havilah Hughes.
And we will see you next time.
Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.